Okay, now next step. The Lagrangian. Woohoo. Do you guys want to attempt it? What's the first thing we have to do for Lagrangian? We have to develop a, in this case, how many, well, first of all, we have to figure out what the generalized coordinate is.
X.
How many masses do we have?
2.
So that means how many T's should we have?
2.
How many V's should we have?
Also.
Good. Can I call this as 1/2 mx dot squared plus 1/2 mx dot squared? Will both mass 1 and mass 2 have the same velocities?
Yes.
Because they are connected to each other, correct? And then I will have a minus m1gx minus m2gx2. Okay, what do I mean by x1 and x2? So in this case, if I call this one x1 and I call this one x2, is that possible? So potentials are with respect to how far apart these are, right? As x increases, does the potential go down? If we're putting our reference point at the floor. As x2 goes up, does the potential go up or down? Right. Every time the length of our string increases, the potential goes down. So that is why I have minus signs here. But now x1 and x2 are connected to each other. Agreed? Now our generalized coordinate is x. So can I replace x1 with just x? So then what will x2 become? L minus x minus pi r squared. That's where our constraints are going to come in. So now, can I rewrite this Lagrangian as 1/2 m1 plus m2 x dot squared plus m1 gx plus m2g L minus x minus pi r. Okay, so what's step 2 now? Write the...
Step 2 is fine. Yes, 2.
Right, step 3?
Get T in the function.
Use the...
The Euler equation.
Excellent. Which one should be used? 1 or 2?
1.
So use equation 1. D over dt of partial L over partial x dot minus partial L over partial x equals 0, which means I can rewrite this as partial over, full derivative over t and m1 plus m2 x dot m1 gx, no, not x anymore, because we're already differentiating with respect to x, minus m2g equals 0. Why do I not use L's or pi r squared? It's not x. If you differentiate it over a constant, it gives you a 0. So I'm just not using it. But you should know why you're not using them. Okay, so this means I can rewrite this as m1 plus m2 x double dot minus m1 minus m2g equals 0. Or I can rewrite this as A equals m1 minus m2 g divided by m1 plus m2, which I can see can be rewritten as delta m over big M g.